I want to record a sample or at least a demonstration of the equipment that is used for the circular motion lab. And it is this thing. This is a rotating post on which is mounted a mass that's going to be our sort of experimental object. It's going to be rotating in a circle. That's just a counterweight there to keep things balanced. We're going to apply a force. We're going to assess centripetal force two ways. Once by stretching the spring, attaching the spring first of all, and then stretching it so that the mass is right over top of this pole, using circular motion, in which point the spring is doing the centripetal job. And then by not rotating it, but stretching the spring manually by attaching a string and hanging some mass off the side of the table here. And if the mass is stretched to this same point, because the spring is stretched the same amount, it's exerting the same force both times, and we can get a measurement, sort of an independent measurement of the force that is required to stretch the spring this far, which is also the force required to stretch the spring that far when we're engaged in circular motion. So I'll just demonstrate one sample run here. I'm going to adjust the post here so that the mass hangs directly over this post. Then I'll attach the spring. And the job now is to rotate the system so that the mass moves so that it is directly over top of that post again. If there were more than one of me here, I could continue maintaining the proper speed of spin so that the mass always is over that post, and someone else could time a number of revolutions. Let's say 10 or 20. It takes so and so much time to make 20 revolutions. That means we know the period of this circular motion. And if we know the period, and later we can measure the radius of this circular motion, we can talk about the centripetal properties going on here. Okay, so I'll stop the rotation. The spring is stretched far enough that the mass is over the post. So if we hang enough mass off the side, we can figure out how much force that is and get an independent measurement of that force. Let me turn on my second camera here. Maybe. There we go. We've got the string over that pulley and the mass hanger there. I'm just going to add mass. And add mass. And you can see the spring is stretching somewhat, but we're not quite there. I'm adding more mass. Getting closer. Running out of mass though. Oh, that was too much. Perfect. There we go. So I could add up the mass of the hanger and all this, 2, 4, 6, 8 kilogram. It's a kilogram and 50 grams or so. So it's like 1.1 kilograms, has a weight, and that weight is the force that's stretching the spring. So that must be, and it's the same stretch as it was when it was engaged in circular motion. So that must be the centripetal, the magnitude of the centripetal force as well. Okay, that's the end. That's the story.